Back, we are now going to start Physics Bootcamp Test 4 review questions. Okay, so question number 1. The test 4 has to do with waves, springs, oscillatory motion, sound, and all of those kind of topics. So question 1 says, if you hang a mass of 200 grams on a spring, it stretches by 4 centimeters. Calculate its spring constant. So for this equation, we're going to be using Hooke's law, F equals negative kx. For now, ignore the negative because the negative has to do with direction. So just concentrate on the absolute value of this. So Hooke's law says that if you exert a certain force on a spring, the spring will stretch by an amount x proportional to the force that you exert. So the x is the amount by which the spring is stretching from its natural equilibrium position. The k happens to be its spring constant, measured in newtons per meter. So if a spring is a very stiff spring, it's going to require a lot of force to stretch it by a certain amount. So for a given amount, it's going to require a lot of force. That means the spring constant is going to be large. So the larger the spring constant, the stiffer the spring is. Okay, so in this case, we're hanging 200 grams. So what is the force? 200 grams. For this problem, the tricky part is you have to make sure to convert the mass into newtons, right? What is the weight of 200 grams? What is the corresponding weight? Well, weight equals mg. So we use what we know from dynamics. So the mass is 200 grams. We got to convert the 200 grams to what? To kilogram, right? Which is 0.2 kilogram multiplied by 9.8. So what does that give me? Well, 2 times 9.8 is 19.6. But since you have 0.2 times 9.8, you have 1.96 newtons. So that means the corresponding weight of a 200 gram mass is 1.96 Newton. And that's going to be the force that you were applying on the spring, right? So then if we want to calculate its spring constant, K, we divide 1.96 by the X, which is how much it stretched. It stretches by 4 centimeter. So centimeter, you convert to what? To meter. So it's going to be 0.04 meter. So this is Newton, this is meter. Okay, so what is that equal to? Well, this is going to be move over the decimal, move over the decimal. So it's going to be equivalent to 196 divided by 4. 4 goes into 19 4 times. That'll give you 16. And then with a remainder of 3 left over. And then 4 goes into 36 9 times. Okay, so the answer is 49 newtons per meter, and the answer is therefore D. So there's a variety of mistakes that someone could have made here. Perhaps they could have not even converted to newtons. So if they had used 0.2 here for the force, and if they forgot to convert 0.2, what would the answer have given you? Well, it'll go over here, divide by 0.04. So it'll be 20. 4 goes into 25 times. And you see one of the answers is actually 5 Newton per meter, right? So there could have been a variety of mistakes that you could make here, and you have to be very careful. Now, what if someone forgot to change the 4 centimeter to meter? Right? Then the K that they would have gotten, they would have divided 1.96 by 4, right? Instead of converting to 0.04, and then they would have gotten 0.49, which is this answer, right? So the problem on purpose has certain answers there placed for certain mistakes that people could make. So you have to be careful for those pitfalls, okay? So thank you very much.